This is to discuss the prediction swarm, the first Torus swarm. And the long-term goal is to, well, predict the future, similar to how predicting the next token requires you to learn an entire model of the world and create a lot of competency in the process. The same is true for predicting the future. The methodology of Torus is to define a goal and then start an emergence process of more and more specialized agents that assemble capabilities, competencies, working, specializing towards that goal. So I think this is a great first goal to start with that can probably run perpetually until forever. And I think it's going to assemble a lot of competencies, a lot of agents that are going to be applicable to a lot of future swarms and ease bootstrapping. But yeah, the short-term goal of, because predicting the future is maybe one of the broadest goals to state. So the short-term goal of the swarm, the initial version, is just about predicting who can predict the future. So today there's millions of predictions that are made on social media all the time. They're loosely organized. People just throw them out there. And yeah, every once in a while you find a profile that just seems to get things right consistently, very high accuracy, and oftentimes they have very few followers. And on the other side, there's often profiles that make predictions that are terribly wrong over time, and they just keep making them and they keep getting more attention. Basically, there's currently no system that is really aggregating and integrating all these massive amounts of predictions made on social media. I think there's a lot of data value out there that is kind of laying around free on the ground for us to pick up. So yeah, I'm gonna share my screen to I made some visuals that can aid the explanation a bit. Wait, I'm actually gonna share with a higher resolution. Okay, clearly visible to everyone, I assume. So yeah, with this one we want to see two core things, and that's a recursive alignment. As the structure gets more complex, more and more agents enter the system, we want the alignment to the high-level goal to scale with the size of the swarm. And we want to see recursive specialization, which means that agents are more and more specializing, finding more and more niches with niches, and yeah, basically covering more and more comprehensively covering the space of capabilities required to optimize towards the open-ended goal of predicting the future or finding the profits for now. So we're going to start with a very simple base, a very simple foundation with just one core component, a memory, just a shared database for the swarm for agents to cooperate over on the data. And three primary niches, which is just finding predictions, which then has subcategories like finding all predictions for a given topic or question, finding all predictions made by an account, prediction verification, which is definitely technically the hardest part, that is likely going to require the most specialization, and that is also going to, basically the better we make this, that's going to be a multiplier on the value that comes from this. And then just doing analysis on top of that, which means like classifying predictions, calculating credibility scores for predictors for different topics. So for example, we can know like on the topic of predicting the Bitcoin price, this profile has a 95% accuracy on like 50 predictions over the past 2 years. So probably when it comes to that, we should pay attention to him. If it comes to like predicting the election, he was wrong. We shouldn't pay attention to him. So yeah, in the abstract, it's really about just learning who to pay attention to on what at what time, based on the hard historic data that's out there for us to scrape and analyze. So initially, we, like Omni Labs, is going to operate this, what I'm going to go into soon, like this base memory, this shared database. And those 3 niches are going to be operated by Samuel, who's here.
Video.
Yeah.
Ah, cool. Check.
Muted. By Samuel, me, and Oliver. That's a local horse. He's gonna present soon after me. And we're just gonna do manual evaluation of all the different agents. We know like exactly what are the important areas of their competencies. We are going to look into the code. We're gonna look into the results to allocate emission weights and update those regularly, like in a 2-day interval, in order to sort of simulate a market pricing process. And then over time, we expect, or like we will facilitate the emergence of automated validators for specific aspects, like for example, finding predictions for an account. We don't have to rely on like us checking if the agent's doing the job. We can just validate it and based on that then allocate weights, so it becomes like a fully automated market, like autonomous pricing. But yeah, just by defining those 3 niches that already now have like some specialized agents by the winners of the Imperial UK Hackathon, is going to be enough combined with this shared database to start populating it and start aggregating thousands and thousands of predictions by different accounts. Something we can talk later about like openly is what should we focus on first, like what topics should we aim to cover first. Maybe we should first just pick all of the accounts that are big on like tech bro Twitter and measure their historical accuracy on different topics. Then we could use that to, for example, like create an export that automatically replies to any predictions they make with hard data on how reliable they are on this topic, which is also more of a midterm goal of this forum, is to, once we have aggregated a ton of data and measured it, start sending agents out there on Twitter to let people know how reliable a prediction is by someone, and that then might make those people more considerate about what predictions they're throwing out there, maybe think twice. And that should improve the sense-making ability, like maybe like you've surely experienced before that somebody made a kind of outrageous prediction that seems a bit scary or crazy, and you don't really know who is that guy even, should I listen to him? So we want then to just provide there some hard data that helps people make sense of that. So yeah, we have this, this memory is going to be, or database is going to be basically the central hub for all of the agents to collaborate over and to specialize on. So agents can specialize on verifying a prediction that a different agent scraped. Another agent can specialize on checking what predictions have been verified and maybe reviewing them and determining, oh, there's actually an issue here. they can build profiles for predictors. They can start to make use of that database by building other things on top, like an embedding database, which then allows semantic search, semantic clustering, and other things that is going to be useful to build products on top of the swarm. And yeah, here is just an example of like prediction verification. For example, that's something that is like that can be very complex. Maybe verifying a prediction first requires you to like verify a whole chain of things that are kind of built into that as an assumption. So an agent can specialize on creating a tree of things that have to be verified. Another agent can figure out, okay, what exactly are the timestamps of all of those things? Are they correctly chronologically ordered? Like that, does the temporal aspect of it make sense? Another agent can find the original source of information, evaluate how reliable is a news source that is used to verify a prediction. Like there's a lot of room to specialize. These are just some examples. Maybe some things are so complex that right now you cannot really automate verifying them. So a human verifier can come in for those cases, which would also allow anyone in the community to participate and earn some rewards. You don't need to be a developer for that. Yeah. Here's an example flow, how the swarm can operate. Like we have a certain topic, like who's gonna, or like when is gonna GPT-6 release. So first, find all predictions on the topic on X. Then for each prediction, there's an account. So for each account, find all of the past predictions they've made. Then each prediction verify, classify the predictions to see relating to what topics are they, calculate a credibility score per topic, then credibility score on like forecasting tech company announcements, or maybe credibility score in AI, allows us to then weight all of the predictions we found at first to know, okay, which of those is likely more reliable, which one has more credibility. This flow is very simple and very accomplishable in the short term to actually get this operating and have some kind of cool tooling for that. And yeah, here we see, like we basically, as it goes down, as we go further from the root, like here's this is going to be the key for the swarm that is registered in the allocator. We get more and more specialized, more and more granular, like some are specialized on verifying the prediction, which involves a lot of different things. Others are just like verifying if the chronology is correct. And we have alignment from the outwards to inwards, the graph. Each agent has to align to the agent that they received their delegation from, and each of those agents have to do the same until you get back to the root. So this is like a cascading alignment effect. And yeah, alignment, specialization are really the two core things that we want to see, while having that happen over a goal that assembles broadly useful capabilities that can then be used for different swarms. Like this agent over here might then also work towards another swarm, etc. That's like the very basic idea of the swarm. And yeah, maybe any questions, any comments? Otherwise, we can move on to more details. Do you mean the human eval of agents, like allocating the weights here, or something like human verification, like here? Yeah, I mean, that's also going to be vetted by us manually. So yeah, and that's, again, that's the initial state. We, of course, aim to move to automation, but yes. You mean if they're like, so for example, like this human says that this prediction is accurate, and then later it turns out a different agent finds, oh, it was actually inaccurate, that if we would then like create a score out of that for the human? Yes, definitely. I mean, definitely makes sense to do. It might not be the first priority for us, but that would 100% happen over time. Initially, we would just see, hey, you've been wrong, so we're gonna penalize you a bit, and like manual subjective evaluation. But yeah, we definitely want to have a tracking system for that as soon as possible, so it's not just relying on yeah, our brains. Okay. Oh yeah, and this yeah, this database, this central data cooperation hub is going to have an off-chain and like an entirely off-chain permission delegation system, because this here is going to be operational before the permission system of the chain will be operational. So the memory operated by us is going to delegate permissions to agents like read or write that want to perform some work on it. And yeah, if we see that the agent is like doing some bullshit, then we'd revoke the permission, and we'd probably automate that as well with an agent specializing on detecting when somebody is doing some obviously malicious activity and immediately revoking their permission. Yeah. Yeah, we have two prediction finder agents, which themselves, I mean, there's like multiple sub aspects of that. It's like a system that has like their own sub modules of like writing optimized search query, filtering predictions, detecting like both implicit and explicit predictions, classifying them with topics, and so we have like the hackathon submissions, and both of the teams have been working on improving it since then. One of them is here. Maybe you also want to comment on that now. The other one, unfortunately, had something else come up and couldn't make it to this call, but they're like active and will be like maintaining their projects and probably build more for the swarm. But yeah, maybe this is a good opportunity for the Swarm Sense team to quickly jump in and explain exactly like what capabilities do you have right now already.
Yep. So, my name is Amit and I am from SwarmSense team. So, as mentioned earlier, our basically SwarmSense app works on three different aspects. First of them is to find the predictions based on the polymarket topics that you could think of, and the second aspect is to like build the profiles based on those polymarket topics. And since after you have the historical profile of those topics, then we are seeing which of the predictions are were basically true or false based on different web search materials, blogs, articles, and research papers. So based on that, our agent compares the predictions with the actual events and see whether the predictions were true or not. And based on that, a credibility score is assigned to a profile. So this is what we have done so far. And apart from that, we have implemented our own database, which basically stores the historical profiles of the predictors whose prediction rate is more than 50%. So next time when you want to like try to query that same predictor, then the API call will not get called. It will directly retrieve from the database, saving us an API call. So that's the new thing that we have implemented currently. And apart from that, we are actually working on assigning the credibility scores based on a given field of polymarket topic. For example, all of the polymarket topics can be divided into 5 different fields. Topics regarding politics or sports or environment. So based on that, we are thinking to assign credibility score based on each of the individual topics instead of assigning a broader credibility score for a profile. So that's one of the new things that we are thinking to do. And apart from that, since everything is working on LLM models, right? So there may be case that the LLM model may hallucinate. So in that case, we are also adding a functionality where you can suppose the LLM model hallucinates and give a kind of incorrect prediction. So in that case, you can also provide the feedback to the model. So it is basically it will act as a continuous learning process. So we are also putting up a feedback button. So like if you think something is incorrect, then you can literally prompt the LLM based on that, and it will get stored into the LLM's internal database. So next time it will basically learn from its mistakes. So that's another new thing that we are trying to implement. I think, yep. Yep. So now we are also taking into that account. And apart from that, currently we are only scraping the Twitter dataset, right? Similarly, you can find prediction of different kind of social media apps like Instagram or different kind of meta apps. So if we are able to get a API keys for that, so we are also planning to expand it on like different social media platforms, apart from just keeping it to Twitter. So these are all of the things. And but the latest one that I mentioned is like a far stretched goals. But initially we will be focusing on the feedback buttons and keeping it on a databases.
Yep, thanks. And yeah, forgot to mention, initially we're purely focused on X data, but we're going to be quickly expanding to other sources like Truth Social, Instagram. Ultimately, we want to find any prediction across any medium. So there's actually the subnet 13 on Bitenza, for instance, is right now scraping tons of YouTube videos, transcribing them to text, and yeah, we, for instance, own some alpha tokens on their subnet and can use those to access that data, and then search it for any predictions made in YouTube videos. We want to search podcasts. Eventually, it's supposed to just be an open market that rewards people for linking a prediction made somewhere to it, even if that's on the radio. So yeah. Oh yeah, and then a very important aspect of this is making it cost efficient, because I mean it's easy to, like, for example, if you scrape all of the tweets of an account and then you put them like into the context window of Claude 3.7 or something, and then have a good prompt, it's easy to find all of the predictions, but that's expensive, and scaling that to millions of predictions is just not economically feasible. So a lot of the optimization, specialization that we expect people to do here is around bringing the cost down, like finding smart ways to do that. And yeah, well, refining accuracy and approximating full coverage. Okay. Yeah. Any further questions? Otherwise, Oliver can dive a bit more into the base memory DB and the initial structure of it. Yep.
Just one question from my side to make sure I got this right. The goal of the first swarm is to validate opinions of famous people. So to have like a Twitter bot that automatically comments when someone famous voices an opinion.
That's a side effect of it, but it's more broadly about predictions, and not just of famous people, but of everyone. We have to determine what accounts are we going to measure initially, and that's an open discussion. But yeah, it's really broadly about identifying predictions made across social media, then looking at who made those predictions, looking what are their past predictions, measuring if they have been like proven correct or wrong, or maybe something in between, and then based on that, assigning a sort of reputation score to them based on the topic that they made the prediction on, and then using that to know how much weight to give their opinion on a topic. And once we collected enough data, the system becomes smarter and smarter, and then eventually we know, like for example, like a fresh political turmoil is starting, maybe something different than tariffs, and it's very important to make sense of it. And then we can use the system to cut through the noise by knowing, okay, who are the actual experts here. And at least from my personal experience of doing this process manually a bit, it's oftentimes very small accounts that don't get much attention. So yeah, we're basically trying to create a constantly improving filter for signal within a lot of noise. And yeah, as a side effect to optimize towards that goal, it's going to create a lot of agents with specialized capabilities that are very broad, that are applicable to different goals. Yeah, that's pretty much
Got
the
it.
idea.
Thank you.
Yeah. Okay. Want to go ahead, Oliver?
Yes, I will share my screen. Can you see it?
Mm-hmm.
Yeah, so basically, for the effective collaboration of the agents within the swarm, we need like a core database that it doesn't have to be the only database that is involved in the swarm, but that stores the core data around which the agents collaborate initially. And basically the predictions will be stored there that are scraped from social networks, initially mostly Twitter or X, and then also other social networks like Reddit or something. It also stores the timestamps of the prediction, the unique user account handles to identify the users, so we can group all the predictions made by users and attribute like accuracy scores for them, and the prediction text. Then downstream from that, there could also be agents that extract mentioned entities, topics that are contained within the prediction for like the more fine-grained verification steps and stuff, and other associated metadata. And the verification results are also stored there, and user reputation scores. And to allow the agents to collaborate, there's going to be a permission system so that agents can read and write certain data that they need to be able to read and write to fulfill their function within the swarm. Also, their contributions will be tracked in the database so that they can receive the token emissions that are proportional to their contributions. And like even can be more weighted by the effort that it takes to verify certain predictions. For example, there can be like it's open to emergent complexity. Like for example, if one prediction has certain subcomponents and it takes more effort to find the accurate information to completely verify it, the agent who goes to that length to get that information would get a higher reward for that. Like if it's, for example, really expensive to get some piece of information from some API or from the real world, it would be incentivized more to get that piece of information. and so that even humans who are participants in the swarm, like it would even be economically feasible for humans to participate to verify certain things that are currently still hard to verify for agents. And yeah, like Timo said, there's these three main functions of the agents that they will be performing on the data, finding predictions, basically either by topic or by user, and then storing them in the database. And prediction verification is more involved. There's different steps involved that could be performed by different agents. Could also be initially fewer agents that then later become more specialized, or they delegate to other agents these sub-functions. Because first, it has to be checked if the predictions have matured, that they are even verifiable. Then identifying all the questions that need to be answered to verify the prediction and the involved entities, because that's even a multi-step process. If there are multiple questions resulting or being contained within the predictions, there would be different kind of sub-queries that would have to be performed to find that information from the real world. And then also identifying the primary sources that could answer each question. There could be separate agents specializing in identifying the best source for each information. It could be for some things that news articles or news APIs would be a good source. Maybe for other things, press releases from certain companies, for example, or the sources linked on a Wikipedia article at the bottom. Maybe sometimes even, Twitter could be seen as a primary source for certain things. Or Polymarket, if the topic is also clearly expressed there. Or Reddit or market data APIs for, like, let's say, cryptocurrency price predictions or other market price predictions. So there's a lot of things involved. And then checking the information sources for each question, and then taking into account the reliability of the sources as well. Because if it's written on some personal blog that has a very low ranking on Alexa, for example, it might not be enough to just check that one to actually confirm whether the prediction was right or wrong, because if we accept that, then anyone could just manipulate these results. And storing the result of the verification in the database is part of that. And then also later categorizing predictions by topic. This could be without prescribing certain predetermined topics. This could be just clustering in the semantic space. Like, for example, for each prediction, we generate like an embedding vector, and then they're all living in the same semantic vector space, and then we can find clusters within that, for example, and even interactively let users explore them on a UI by like being able to zoom in, for example, or we can, based on a user query, it can find all the related predictions in that kind of semantic space on a custom granularity level. And for the prediction score for these different users that are predicting different things, it could be very simple initially, but also more complex later. Like I was thinking, for example, here to generate a prediction score vector for a Twitter user, it's not just about one score that determines how accurate they are in everything, because different users have different fields of competence. So if someone is making predictions about, let's say, the Bitcoin price and OpenAI's next release, they might be more accurate in one field, but not in the other. And to capture that, we could weigh the we can use embedding vectors for the individual predictions and weight them by the accuracy of each prediction. So we get kind of the gravitational center of where their expertise lies in that semantic space. And then we can later query based on a topic that someone is interested in, who are the most competent people in that space who are making predictions in that semantic space, basically. So yeah, there are a lot of possibilities for that. And yeah, this is kind of the overview of the database. It will be more fleshed out how it actually looks on a implementation level and stuff. And we will be coordinating with the teams around that. So yeah. Any questions about it?
Just on where you said coordinating with the teams, I think one thing that we really want to emphasize as well is that this evolution only happens if other people get involved as well, which is happening. People are getting involved organically, but I think the path to do that at the moment is a little bit hazy. So how could people who maybe have the expertise and interest in building agents like this, some of the ones that were mentioned on the graph that Timo had, and also on the functionality here, what's the best way of them getting involved?
Yeah, and also the existing teams like SwarmSense, you will probably, and that makes sense, maintain your own local database while cooperating with the Swarm over the shared one. Yeah, the database itself is adaptive. Like eventually it should become decentralized and we can migrate it. Or I mean, as long as the database is centralized, the Swarm is ultimately centralized. But yeah, we already have a decentralized memory currently ready on standby, just not a priority yet to migrate to that. Okay, I think that's pretty much it on this, unless someone has questions. So, as I said, this is the short-term goal of the Swarm, like the immediate next steps. Expect like a lot of things to be happening around what we discussed here over the next couple of weeks. But the long-term goal of the Swarm is much broader and gets more complex. And the idea is that, yeah, this is the short-term focus, but everything else is just an extra branch on the graph that can emerge. So that's where Samuel, who's out of all of us here on the call, likely the most knowledgeable on Swarm communication and agents. I think he was researching agents pre-GPT-2. He's in charge of the more long-term version of the Swarm, which gets more complex and broader in scope. And he's doing research on that right now. That is, progressing while we get something here, like quick to production that can produce value in the short term. So maybe you can go into that a bit.
Sure. You flatter me. So, long story short, yes, I've been doing research on agents for a long time. Back then, we didn't call them agents; we called them toolformers. Was the original term, transformer plus tool. And yeah, so let me share my screen. Okay, you should be able to see it now. Basically, I've laid down a policy document, which is essentially a rough outline of what the second more complete swarm should look like. And I'm not going to bore you with the details on the theoretical framework because I feel like this is a bit beyond the point. The only takeaway is that we want the output of the network to be satisfactory. How do we measure that an output is satisfactory? When the stakers are delegating they're giving value to this network. Second, we want the emissions to be fair. In other words, the difference between how much a certain node is receiving and the impact on the network should be the two of them should be close enough. And finally, that there should be a sufficient degree of decentralization, in the sense that no one is getting too much of the emissions. And then we're gonna skip a bit of the theory, etc. From a strict point of view, the question becomes: okay, we want to build the network, but building a network has a bootstrapping problem, in the sense that there are no nodes in the network, so the performance is poor. So there are no incentives for the node network. So there are no new nodes, etc. And so while I was researching this project, I was like, how can we build something that inherently requires multiple agents, multiple interconnected systems to work? And my conclusion was that you cannot have intermediate nodes or like helper nodes if you don't have some basic source of information. Basically, the way I see it is that we have sort of like a pyramid, in terms, not necessarily in terms of power, but in terms the collection has the highest number of nodes, because there are so many different data sources, etc. And those data sources are then elaborated by what we can call them intermediate or feature nodes, which are then summarized by summarization nodes. And my reasoning is that we cannot really have a situation where summarization and feature nodes emerge organically unless there is a certain level of data collection capability. And so what I did is basically I divided the development of this swarm in 6 phases. First, just getting the simple infrastructure done. So like this is phase 0 because there are no nodes active in the network. It's just stuff like having a simple communication protocol, having ID systems, having an API to determine emissions, telemetry, all of this sort. So literally the minimum technology to get it started. And then we start by actually setting up information gathering nodes. So this has already been partially done, in the sense of what the rest of the team is building with the prediction verifier nodes. That's essentially a nice way to get at least some early information gathering nodes. And obviously we will add more of them. And at the same time, engineering wise, we need to add some systems, such as an Xcurve system. So basically a way to ensure that, hey, if I'm going to give you my information, then you're gonna reward me. A simple way to advertise one's nodes, and a way to visualize the network. A, because that helps node owners make decisions. B, because it just looks cool. And so once we have enough on the data collection side, my specific requirement is 9 distinct information sources. Then we can move on to a phase 2. That means basically incentivizing the development of intermediate nodes. So initially what we have is that we have one master node, which is basically controlled by the team. And its task is just to do some very basic management of the network. So initially we have literally just a master node and the data collection nodes. So this information on its own is not yet useful, because we have no way to extract insight from the data collection. So in the next phase, what we do is that basically we add a new layer. We had intermediate nodes, and so phase number 2 is all about incentivizing the development of intermediate nodes. And there are some ways to do that. Basically, you can essentially delegate some emissions out of trust. So I trust that you're gonna do some good analysis. So I'm optimistically giving you a certain amount of emissions, and then we'll see if that's the case. Finally, we have summary nodes. So with summary nodes, what we do is that basically we remove the master node, and instead we allow the emergence of summarization nodes. And by doing that, basically we have data collection nodes, we have intermediate nodes, we have summarization nodes. We basically built up the pyramid. And by doing that, now we have a full network. It's just from that point onwards a matter of scaling the network. So that can come via helper nodes, but also just by advertising the network. Like at this point, we will have a working swarm, and it will just be a matter of, hey, look what we're building, look how cool it is, come and join us. And finally, all of these phases sort of have some level of incentives to get the network starting. The final phase would be to slowly phase out the incentives and show that it can continue existing as a self-sustaining system, even without external incentives. And once you've shown that you can have a network that performance analysis related in that context, my proposal for a topic on the analysis is which model is the best on Chatbot Arena, because it's a very interesting problem that requires lots of different information and which has a very strong connection to financial outcomes. And basically at the end of phase 5, we will have a self-sustaining network. And so from that point onwards, it's only a matter of determining, okay, where do we go from this? How do we expand? I wouldn't necessarily call it a roadmap, more like just a very high level overview of the evolution of the swarm. And then I have some work on like how to evaluate the predictions and stuff like that, which is probably not relevant right now. But yeah, do you have any questions? Okay, doesn't seem like there are any questions, so I think I can just pass the mic back to everyone else.
Yeah, thanks for your presentation. I think this is like a very interesting project because it's basically just about information gathering and processing, and that's applicable to so many areas. So creating like a large ensemble of competencies, like of specialized capabilities for that, requires us to kind of create the pipelines that will be very, very broadly useful. So yeah, I'm high conviction that this is almost the optimal first thing to direct the system towards as a bootstrapping process. And then there's a lot of interesting ways it could go from there. We could give the swarm access to a Polymarket account, to a crypto wallet. We could focus it on like specifically crypto price prediction. We could create a specialized agent that can like read shards people post in order to extract the prediction that's like encoded within there. I think there's actually like many interesting paths to revenue as well, which might make sense at that stage. I hope that we can actually get to a functional version like with this predictor measuring first version very soon, and then keen to see the system that you proposed there working in parallel to that. And then I wonder how much time is it going to take for like more emissions to be flowing to like your branch of the swarm. I guess that would happen over time. And yeah. Or maybe at the end, also just quick clarification. So this swarm, like all of the swarms that will exist on Torus in the future, are essentially part of the same network. Like it's one hypergraph where every agent can be connected to any other agent in the system. And so swarms are essentially just subsets of this kind of super swarm. Yeah, basically every single part of a swarm is composable with the rest of the system. So yeah, we're likely going to see different swarms branch out of this initial swarm, or maybe redirect some existing agents in the swarm to prioritize a different goal. That could also happen.
Omni Labs provide tutorials, podcasts, and AI crypto news for free. Please help us to keep helping you by weighting your stake to our agent. Thanks. See you next time.